Okay, welcome back. We've just seen the general rule for volume of a rotated region between two functions. So now for our example, we can set up our integration rule. We're going to multiply pi by the integral, the definite integral, from 2 to 4 on the y-axis. Those are the limits of integration we've calculated. f1, the outer function, looking at our diagram, that's the parabola, that's farther from the y-axis, comparing the two. We want, and not using the x function in the diagram, but going back to the left side of the screen, looking at the conversion of that function to square root of y minus 2, conversion from an x function to a y function. We're going to square the outer function. Then we subtract the inner function, and again we want the converted function from an f function to a y function, and that calculation from step 1 is y minus 2 over square root of 2. Again, we want to square this function, all with respect to y. Continuing, our volume is pi times the integral from 2 to 4 of the square root of y minus 2 squared is y minus 2 minus, now y minus 2 in the numerator squared is y squared minus 4y plus 4, and these three terms are all divided by square root of 2 squared, which is 2. With respect to y, pi times the integral from 2 to 4 of y minus 2 minus, for each term here in the brackets I want to divide by 2. So we'll have 1 half y squared plus minus minus plus 4y divided by 2 is 2y minus 4 divided by 2 is 2. And again, all with respect to y. One more simplification. We'll get to pi times the definite integral from 2 to 4 of, now let's combine terms. We have one y squared term, which is minus 1 half y squared. We have two y terms, y and 2y, so plus 3y. And we have two constant terms, minus 2, minus 4, with respect to y. And now we're ready for integration. So the volume equals pi times, integrating each of our terms, negative 1 half y squared is going to integrate to negative 1 over 6 times y to the power of 3, plus 3y will integrate to plus 3 over 2y squared, and minus 4 will integrate to minus 4y, and our limits of integration 2 to 4. Going up to our algorithm, since this is a definite integral, we'll take out include constant of integration. Our simplification was done in step 2 as part of the algebra before integration. Let's go on to step 5. We do have limits of integration, so we will apply those limits. Pi times, and inputting the 4 into all y places, negative 1 over 6 times 4 cubed, plus 3 over 2 times 4 squared, minus 4 times 4, minus, and in brackets to ensure that I distribute the minus sign, we'll use an input of 2 into all y places. Negative 1 over 6 times 2 to the power of 3, plus 3 over 2 times 2 to the power of 2, minus 4 times 2. And we end up with pi times 4 cubed is 64, negative 64 over 6. 4 squared is 16. 16 times 3 is 48, plus 48 over 2, minus 16 minus 1/6 will be positive. 2 to the power of 3 is 8 times 1/6 will be plus 8/6 minus positive 3/2. That will give us a negative. 2 squared is 4. 4 times 3/2 is 6 minus 6. And the final term, negative 4 times 2 is negative 8. Distributing the negative gives us a plus 8. I'll add in some equal signs here at the first line of step 5 and the line we just completed. And when we sum those values and multiply by pi, we end up with 2/3 pi. This is a volume calculation, units cubed. So, the volume obtained when the given region is rotated 360 degrees about the y-axis is 2/3 pi units cubed. We've completed all requirements. This concludes volume example 2.